Hi everyone, and welcome to the SAGIS-SIMCAT training series. My name is Pau Juan Garcia. I am a water quality modeler at Atkins Reales, and I will be taking you through the first video, Introduction to SAGIS-SIMCAT. To begin with, let's take a look at what SAGIS-SIMCAT really is. So what is SAGIS-SIMCAT? SAGIS is a discrete ArcGIS-based digital information management and visualization platform that operates in combination with Environment Agency's SIMCAT water quality model. I know that is a lot of words, but please bear with me, it will become clearer as we go together through the video. Together, SAGIS and SIMCAT are known as the SAGIS-SIMCAT system, and they serve as an integrated system for modeling water quality in rivers and lakes, with coverage of all of England, Scotland, and Wales. SAGIS is an acronym of Source Apportionment Geographical Information System. It is a product of Hugh Weir's research program and was released in 2011. SAGIS was created in collaboration with the industry's environmental regulators, namely the Environment Agency, Natural Resources Wales, and the Scottish Environment Protection Agency. The SAGIS Add-in is distributed as an Esri ArcGIS Pro add-in. The first thing that we need to make sure is that we are using the right version of ArcGIS Pro that will work with SAGIS. To do this, we'll navigate in any ArcGIS Pro project to the Project tab and then to About. Under Product Information, we can see that the installed version of ArcGIS Pro is, in this case, 3.1.3. At the moment of recording this video, the latest version of the SAGIS add-in is compatible with ArcGIS Pro 3.1. This means that if your version is 3.1. Any patch, 1, 2, 3, or even 4, that is alright. But if you are using any newer or older versions than ArcGIS Pro 3.1, you will need to make sure that you got the right version installed. Otherwise, ArcGIS Pro and SAGIS may not work correctly together. To install the add-in, you will have received a zip folder, most likely containing at least two items: the ArcGIS Pro add-in file and a Word document containing release notes. I encourage you to read the release notes as they contain important information about the latest version of the add-in. To install the add-in, first we will close ArcGIS Pro. Once ArcGIS Pro has been closed, we will double-click on the add-in, which will trigger this pop-up asking us to confirm the installation. By pressing Install Add-in, the add-in will be successfully installed. After which we will close this window and open ArcGIS Pro again. You will notice that for the purpose of this video, I haven't closed ArcGIS Pro, but it is highly recommended that ArcGIS Pro is closed during the installation. After the add-in has been installed, if we navigate to Project and the Add-in Manager, you will see that the SAGIS Pro add-in now appears in this window. And on top of that, you will now have an extra tab named SAGIS in your ArcGIS Pro configuration, giving you access to all of the different tools, as well as the SIMCAT related tools that are provided by the SAGIS add-in. When you request a SAGIS model, you will receive up to 3 file geodatabases. A file geodatabase is the most common format that Esri ArcGIS Pro uses to contain geospatial information. That is tables or feature classes containing features, lines, or polygon layers that we will be using to contain the information necessary for a SAGIS model to work. So, in my screen, I am sharing the 3 file geodatabases that compose the Saglandia model. Saglandia is a model that we use for SAGIS training, and it will be featured extensively in this series of videos. We have 3 databases. The first one is the regional database, which contains data that is bespoke to a specific model. The second one is the common database, which contains data that is usually common to several different models. And finally, the lake, transitional waters, and coastal waters, which contains information regarding the lake, estuaries, and coastal waters of that given model, or sometimes common models. And lastly, we're going to take a look at the SIMCAT output folder. So this is a set of outputs that we will create in the following videos, but it is important because we're going to be constantly referring to the DAT file that you at least have an idea of what this is like. SAGIS, as we've said, can be considered a data management system or a data visualization tool that operates around SIMCAT, or Catchment Simulator, the Environment Agency river water quality model. This model uses a primary input, which is the SIMCAT DAT file, which is a normal text file that you can open, read, and you should ideally understand the structure of, so you can make your own modifications, understand changes, and basically judge what is the setup of your model. So in this folder, we are going to filter by type. So if we filter by that file, we'll find this test.dat file text file, which I am going to open. In this case, I'll open it with Notepad++, which is a fairly common and free and open source text editor that is quite handy to edit simple text files that don't need any fancy software to be opened. So quickly, we'll go through the different sections of that file. The most important one is probably the header, where you can see the location of the DAT file, the ID of who has created it, the date where it was created, the different parameters that were used, or data sources to create this particular file, that being the regional common databases that we have just talked about in this video. It will also include a reference to the path of the ArcGIS Pro SAGIS project location. It will tell you what is the identifier of the add-in, or SAGIS add-in that you're using, and also other metadata that we haven't discussed yet, but we will discuss in future videos. The next section of the DAT file is the general data section, which contains some general switches that SIMCAT can use to activate or deactivate specific functions. For example, this switch can be set to 1 or 0, and it will activate or deactivate the use of monthly structured data rather than annual data in the whole model. Users are not expected to be aware of these switches from the DAT file itself, but rather modify or control the DAT file via the SAGIS interface. But it's still useful to be able to check if a particular setting has been activated or deactivated in the DAT file, or at least be aware that these settings that we manage via the user interface have an effect on SIMCAT via the DAT file. That file is in itself the proof of what the simulation data contained, as any model that uses the same inputs should produce the same outputs. Therefore, by keeping a DAT file, the DAT file becomes a record of the simulation input data that can be shared and used to verify outputs, even if you don't have the outputs of the other model, just by checking what settings and inputs have been used in the first place. The next section, section 2, is the determinant section. The most interesting thing about this section is that it allows us to see which determinants have been included in the simulation, and also in which units, and several other settings. All of these settings can be understood via the description that is included in the DAT file that has been generated underneath the title of each section. The rest of the section will describe the river reach structure that the SIMCAT model will follow, the water quality data, the flow reach data, discharge water quality and effluent flow, as well as all of the different features that have been included in the model. And now back to the .dat file folder, there's one more file type that it's worth mentioning, and this is the NPD file type. So NPD stands for non-parametric distribution. These files are created during the creation of the .dat file, and they are referenced throughout the .dat file itself. They are used to represent inputs to the model that cannot be represented as a set of parameters. For example, for a discharge, we could assume that the data would follow a normal or a not-normal distribution. For diffuse inputs, we could assume that they follow a power function, and therefore these can all be represented using parameters like the mean, the standard deviation, and so on. When this is not possible, we create an NPD file, and they are created for flows, concentrations, and many other applications. If we open one at random, we'll see that this file has two rows. The first one indicating how many values are in the non-parametric distribution, and the second one with those values. They are ordered from lower to highest, therefore we start with zeros, but as we scroll to the right, you'll see that there are some values here. And these values will be picked at random, depending on the Monte Carlo shot that SIMCAT is processing at any given time. This is one of the many systems that we have to include data that does not follow a specific parameterization and yet include it into the model. That's everything for the first video. I hope everything was clear and you enjoyed it. In future videos, we'll tackle more complex projects and we'll see how to actually drive SAGIS-SIMCAT. Thank you for watching and happy modeling.